William Kingdon Clifford FRS was an English mathematician and philosopher. Building on the work of Hermann Grassmann, he introduced what is now termed geometric algebra, a special case of the Clifford algebra named in his honor. The operations of geometric algebra have the effect of mirroring, rotating, translating, and mapping the geometric objects that are being modeled to new positions. Clifford algebras in general and geometric algebra in particular have been of ever-increasing importance to mathematical physics, geometry, and computing. Clifford was the first to suggest that gravitation might be a manifestation of an underlying geometry. In his philosophical writings he coined the expression, mind stuff. Biography. Born at Exeter, William Clifford showed great promise at school. He went on to King's College London and Trinity College, Cambridge, where he was elected Fellow in 1868, after being second Wrangler in 1867 and second Smith's Prizeman. Being second was a fate he shared with others who became famous mathematicians, including William Thomson and James Clerk Maxwell. In 1870, he was part of an expedition to Italy to observe the solar eclipse of December 22, 1870. During that voyage he survived a shipwreck along the Sicilian coast. In 1871, he was appointed Professor of Mathematics and Mechanics at University College London, and in 1874 became a Fellow of the Royal Society. He was also a member of the London Mathematical Society and the Metaphysical Society. On 7 April 1875 Clifford married Lucy Lane. In 1876, Clifford suffered a breakdown, probably brought on by overwork. He taught and administered by day, and wrote by night. A half-year holiday in Algeria and Spain allowed him to resume his duties for 18 months, after which he collapsed again. He went to the island of Madeira to recover, but died there of tuberculosis after a few months, leaving a widow with 2 children. Born 11 days later, Albert Einstein would go on to develop the geometric theory of gravity that Clifford had suggested 9 years earlier. Clifford enjoyed entertaining children and wrote a collection of fairy stories, The Little People. Clifford and his wife are buried in London's Highgate Cemetery just north of the grave of Karl Marx, and near the graves of George Eliot and Herbert Spencer. Mathematician. Clifford was above all and before all a geometer. The discovery of non-Euclidean geometry opened new possibilities in geometry in Clifford's era. The field of intrinsic differential geometry was born, with the concept of curvature broadly applied to space itself as well as to curved lines and surfaces. Clifford was very much impressed by Bernhard Riemann's 1854 essay on the hypotheses which lie at the basis of geometry. In 1870 he reported to the Cambridge Philosophical Society on the curved space concepts of Riemann, and included speculation on the bending of space by gravity. Clifford's translation of Riemann's paper was published in Nature in 1873. His report at Cambridge, on the space theory of matter, was published in 1876, anticipating Albert Einstein's general relativity by 40 years. Clifford elaborated elliptic space geometry as a non-Euclidean metric space. Equidistant curves in elliptic space are now said to be Clifford parallels. Clifford's contemporaries considered him acute and original, witty and warm. He was also working late into the night, which may have led to his death. He published papers on a range of topics including algebraic forms and projective geometry in the textbook Elements of Dynamic. His application of graph theory to invariant theory was followed up by William Spottiswoode and Alfred Kemp. Algebras. In 1878 Clifford published a seminal work, building on Grassmann's extensive algebra. He had succeeded in unifying the quaternions, developed by William Rowan Hamilton, with Grassmann's outer product. He did this by defining a geometric product, composed of the sum of the inner products and that outer product. The former equips geometric algebra with a metric, fully incorporating distance and angle relationships for lines, planes, and volumes. The latter gives those planes and volumes vector-like properties, including a directional bias. The resulting geometric algebra, as he called it, realized the long-sought goal of creating an algebra that mirrors the movements and projections of objects in three-dimensional space. Moreover, Clifford's algebraic schema extends to higher dimensions. The algebraic operations have the same symbolic form as they do in 2 or 3 dimensions. The importance of general Clifford algebras has grown over time. While their isomorphism classes, as real algebras, have been identified in other mathematical systems beyond simply the quaternions, the realms of real analysis and complex analysis have been expanded through the algebra H of quaternions, thanks to its notion of a 3-dimensional sphere embedded in a 4-dimensional space. Quaternion versors, which inhabit this 3-sphere, provide a representation of the rotation group. So, Clifford noted that Hamilton's biquaternions were a tensor product of known algebras, and proposed instead 2 other tensor products of H. Clifford argued that the scalars taken from the complex number C might instead be taken from split complex numbers D or from the dual numbers N. In terms of tensor products, produces split biquaternions, while forms dual quaternions. The algebra of dual quaternions is used to express screw displacement, a common mapping in kinematics. Philosopher. As a philosopher, Clifford's name is chiefly associated with 2 phrases of his coining, mind stuff, and the tribal self. The former symbolizes his metaphysical conception, suggested to him by his reading of Spinoza. Sir Fredick Pollock wrote about Clifford as follows. Briefly put, the conception is that mind is the one ultimate reality, not mind as we know it in the complex forms of conscious feeling and thought, but the simpler elements out of which thought and feeling are built up. The hypothetical ultimate element of mind, or atom of mind stuff, precisely corresponds to the hypothetical atom of matter, being the ultimate fact of which the material atom is the phenomenon. Matter and the sensible universe are the relations between particular organisms, that is, mind organized into consciousness, and the rest of the world. This leads to results which would in a loose and popular sense be called materialist. But the theory must, as a metaphysical theory, be reckoned on the idealist side. To speak technically, it is an idealist monism. Clifford himself defined mind stuff as follows. That element of which, as we have seen, even the simplest feeling is a complex, I shall call mind stuff. A moving molecule of inorganic matter does not possess mind or consciousness, but it possesses a small piece of mind stuff. When molecules are so combined together as to form the film on the underside of a jellyfish, the elements of mind stuff which go along with them are so combined as to form the faint beginnings of sentience. When the molecules are so combined as to form the brain and nervous system of a vertebrate, the corresponding elements of mind stuff are so combined as to form some kind of consciousness, that is to say, changes in the complex which take place at the same time get so linked together that the repetition of one implies the repetition of the other. When matter takes the complex form of a living human brain, the corresponding mind stuff takes the form of a human consciousness. Having intelligence and volition, the other phrase, tribal self, gives the key to Clifford's ethical view, which explains conscience and the moral law by the development in each individual of a self, which prescribes the conduct conducive to the welfare of the tribe. Much of Clifford's contemporary prominence was due to his attitude toward religion. Animated by an intense love of his conception of truth and devotion to public duty, he waged war on such ecclesiastical systems as seemed to him to favor obscurantism, and to put the claims of sect above those of human society. The alarm was greater, as theology was still unreconciled with Darwinism, and Clifford was regarded as a dangerous champion of the anti-spiritual tendencies then imputed to modern science. There has also been debate on the extent to which Clifford's doctrine of concomitance, or psychophysical parallelism, influenced John Hewlings Jackson's model of the nervous system and through him the work of Janet Freud, Ribot, and A. arguing that it was immoral to believe things for which one lacks evidence. His 1877 essay, The Ethics of Belief, contains the famous principle, "It is wrong always, everywhere, and for anyone, to believe anything upon insufficient evidence." As such, he was arguing in direct opposition to religious thinkers for whom blind faith was a virtue. This paper was famously attacked by pragmatist philosopher William James in his Will to Believe lecture. Often these two works are read and published together as touchstones for the debate over evidentialism, faith, and over belief. Premonition of relativity. Though Clifford never constructed a full theory of space-time and relativity, there are some remarkable observations he made in print that foreshadow these modern concepts. In his book Elements of Dynamic, he introduced quasi-harmonic motion in a hyperbola. He wrote an expression for a parametrized unit hyperbola, which other authors later used as a model for relativistic velocity. Elsewhere he states, "The geometry of rotors and motors forms the basis of the whole modern theory of the relative rest and the relative motion of invariable systems." This passage makes reference to biquaternions, though Clifford made these into split biquaternions as his independent development. The book continues with a chapter on the bending of space, the substance of general relativity. Clifford also discussed his views on the space theory of matter in 1876. In 1910, William Barrett Franklin quoted the space theory of matter in his book on parallelism. He wrote, "The boldness of this speculation is surely unexcelled in the history of thought. Up to the present, however, it presents the appearance of an Icarian flight." Years later, after general relativity had been advanced by Albert Einstein, various authors noted that Clifford had anticipated Einstein. In 1923, Hermann Weyl mentioned Clifford as one of those who, like Bernhard Riemann, anticipated the geometric ideas of relativity. In 1940, Eric Temple Bell published his The Development of Mathematics. There on pages 359 and 360 he discusses the prescience of Clifford on relativity. Bolder even than Riemann, Clifford confessed his belief that matter is only a manifestation of curvature in a space-time manifold. This embryonic divination has been acclaimed as an anticipation of Einstein's relativistic theory of the gravitational field. The actual theory, however, bears but slight resemblance to Clifford's rather detailed creed. As a rule, those mathematical prophets who never descend to particulars make the top scores. Almost anyone can hit the side of a barn at 40 yards with a charge of buckshot. Also in 1960, at Stanford University for the International Congress for Logic, Methodology, and Philosophy of Science, John Archibald Wheeler introduced his geometrodynamics formulation of general relativity by crediting Clifford as the initiator. In his The Natural Philosophy of Time, Gerald James Whitrow recalls Clifford's prescience by quoting him to describe the Friedmann-Lemaitre-Robertson-Walker metric in cosmology. In 1970, Cornelius Lanczos summarizes Clifford's premonitions this way. He, with great ingenuity, foresaw in a qualitative fashion that physical matter might be conceived as a curved ripple on a generally flat plane. Many of his ingenious hunches were later realized in Einstein's gravitational theory. Such speculations were automatically premature and could not lead to anything constructive without an intermediate link which demanded the extension, a three-dimensional geometry to the inclusion of time. The theory of curved spaces had to be preceded by the realization that space and time form a single four-dimensional entity. In 1973, Banish-Hoffman wrote, Riemann, and more specifically Clifford, conjectured that forces and matter might be local irregularities in the curvature of space, and in this they were strikingly prophetic, though for their pains they were dismissed at the time as visionaries. In 1990, Ruth Farwell and Christopher Nee examined the record on acknowledgement of Clifford's foresight. They conclude, it was Clifford, not Riemann, who anticipated some of the conceptual ideas of general relativity. To explain the backward attitude to Clifford, they point out that he was an expert in metric geometry, and metric geometry was too challenging to orthodox epistemology to be pursued. In 1992, Farwell and Nee continued their study with the geometric challenge of Riemann and Clifford. They hold that once tenses had been used in the theory of general relativity, the framework existed in which a geometrical perspective in physics could be developed and allow the challenging geometrical conceptions of Riemann and Clifford to be rediscovered. Selected writings. Most of his work was published posthumously. 1877. The Ethics of Belief. Contemporary Review. 1878. Elements of Dynamic. London. Macmillan & Co. Online presentation by Cornell University. Historical Mathematical Monographs. 1879. Seeing and Thinking. Popular Science Lectures. 1879. Lectures and Essays, with an introduction by Sir Frederick Pollock. 1882. Mathematical Papers, edited by R. Tucker, with an introduction by Henry J. S. Smith. 1885. The Common Sense of the Exact Sciences, completed by Carl Pearson. 1887. Elements of Dynamic, Volume 2, in Avald, William B., ed. 1996. From Can to Hilbert. A Source Book in the Foundations of Mathematics, 2 vols. Oxford University Press. 1872. On the Aims and Instruments of Scientific Thought, 524-41. 1876. On the Space Theory of Matter, Legacy. The academic journal Advances in Applied Clifford Algebras publishes on Clifford's legacy in kinematics and abstract algebra. Quotations. I hold that in the physical world nothing else takes place but this variation of the curvature of space. Mathematical Papers. There is no scientific discoverer, no poet, no painter, no musician, who will not tell you that he found ready-made his discovery or poem or picture, that it came to him from outside, and that he did not consciously create it from within. It is wrong always, everywhere, and for anyone to believe anything upon insufficient evidence. The Ethics of Belief. I was not, and was conceived. I loved and did a little work. I am not and grieve not. Epitaph. If a man, holding a belief which he was taught in childhood or persuaded of afterwards, keeps down and pushes away any doubts which arise about it in his mind, purposely avoids the reading of books and the company of men that call in question or discuss it, and regards as impious those questions which cannot easily be asked without disturbing it, the life of that man is one long sin against mankind. Contemporary Review.